Should I just start? Okay. All right. Let's continue. Hi, everybody. My name is Marc. I'm a technical head of IT at Meyer Wolf. Maybe just a quick note on Meyer Wolf. We do custom software development, custom solution development, and as a company, we're quite focused on product digitalization and digitalization of the factory. So about half of our 930 employees are currently working on such projects, meaning on IoT or industrial IT projects, from building web apps for these mobile apps, doing data analytics, machine learning use cases, connecting devices, plans, building IoT platforms, and so on. So the whole end-to-end journey. Sometimes everything, sometimes just part of it. And I will build a bit on what Walker presented now. So you've been introduced to the unified namespace concept. Some of you probably already knew about it. And I'm going to present on how we at Meyer Wolf typically build smart factory platforms, how we build the unified namespace, and how we do machine connectivity. So I'm going to talk a lot about technology and to some extent also about more conceptual changes like the unified namespace. The picture here shows a CIO or plant manager that realizes a few years too late that he should have built a unified namespace, a smart factory platform, and to transform his enterprise digitally. And unluckily, this was too late. Not sure if it's Ford that Walker keeps talking about, but yeah. So let's dive in. So actually, there are a lot of reasons why smart factory or industrial IT initiatives fail. Sometimes it's that the company doesn't have a digital strategy, that it's just this one person that's responsible for smart factory and doesn't have any C-level support. Like one of my favorites is, like we had two companies now that were busy with the integration of a new ERP system, which kept them from transforming their enterprise. Companies get stuck in a POC purgatory, moving from POC to POC to POC to prove that you can actually get data from the shop floor into the cloud. Yeah, nobody knew that before. And the good news is I'm going to help you at least with one of these reasons. And the reason is that a lot of companies lack a unified end-to-end infrastructure and architecture on which they can build their smart factory use cases. And so let me start with the 5 key success factors from my perspective that you need to successfully build such a platform, such a solution. The first one is to use Kubernetes from cloud to the edge to build a really unified platform. The second one is to use multi-cluster management tools. The third one is to get the machine connectivity right. I'm going to talk more about this, obviously. The fourth one is to build a UNS. And the fifth one, just as important, is to build a data catalog. So let's dive in. Maybe to start with those not familiar of the terms on the left, those signify programmable logic controllers. Those are essentially industrial PCs that control and automate industrial machines. And usually we also have some sensors on the shop floor, actuators, and so on. So why do we even have different types of environments in a smart factory platform? So the reason is quite simple. We have different workloads that require different environments. So a lot of our customers, for example, follow a cloud-first approach. That means they want to do as much as possible in cloud. So we often do data analytics. In the cloud, we build services that implement some smart use cases, or we do machine learning development, we do experiments, machine learning model training, etc. Everything in the cloud, we do CI/CD there, and so on. So we try to deploy as much as possible in the cloud. So this is probably about 80% of the stuff that we deploy. Then we also have things that we can't do on the cloud side. The first thing, obviously, is to do machine connectivity. So very often, we're not allowed to connect to industrial machines on the shop floor from the cloud or even from corporate networks. So We need a second environment that sits somewhere in a IT/OT DMZ or some part of the production network from where you're allowed to connect to industrial machines. So you can connect to machines, get data from them. Then often we also want to run production critical services on-prem as well. Production critical means that these are services without which the production would stop. So, for example, in case we have a cloud connectivity failure, which happens from time to time, these services should keep running and they should be able to run in a highly available manner. So these are workloads that we usually put on premise in a highly available environment. Then you also might want to do some data reduction to move less data to the cloud. Maybe have some requirements to do low latency machine learning, for example, for visual inspection or something like this. So we need some central environment in the plant. The third environment, which I call edge, is essentially an environment that runs on a single instance edge device, which we actively try to avoid because they're expensive, you need a lot of them, they need electricity, you need to install them, you need to operate them, so you actually don't want them. Instead, you want just maybe 3 19-inch pizza boxes in a rack somewhere that can be managed very easily, and of which you don't have too many. But in some cases, we're not able to connect from a central environment in a plant to PLCs. For example, we often have the rule that this is only allowed if we use encrypted protocols. So it's not allowed if you use, for example, unencrypted S7, if they have like some S7 300, 400 systems that only speak unencrypted S7. We have to put an edge device on a network segment on which the machine runs, so it's allowed to connect to this machine. Then sometimes also we have to put an edge device on these network segments, for example, to do visual inspection, if it's not allowed to connect the camera directly to this central environment, but you have to connect it to an edge device, and then the edge device to the network of the machine. So in these few cases, we can't avoid using edge devices, but we actually try to avoid them. Now, the first success factor. In order to simplify development and operations of these environments, you really need to have a unified technology stack. So you can't handle having 3 technology stacks on each of these environments. So what we do is we use Kubernetes from the cloud through the central cluster in the plant to the edge device in order to unify the environments as much as possible from a development and an operations perspective. And since we often have different Kubernetes distributions, for example, maybe AKS or EKS on the cloud, and then we have K3S on-prem, we also have to unify these environments through adding add-ons for things like monitoring, logging, deployments, etc. So these different distributions are as identical as possible, again, from a development or operations perspective. Now, we already have 3 different types of environments. We have the cloud, we have the central cluster in the plant, and we have edge devices. Now, this means that there can already be multiple environments per plant. So you have the cloud on the left, and you have maybe some edge devices, and you have a central cluster. And as many companies don't have just one plant, this gets even worse because each additional plant adds additional environments. So if you have 10 plants, and you have 10 environments per plant, you're already at 101 environments that you have to operate, that you have to deploy to. So these are a lot of environments to manage. And this is where the second success factor comes in. You need some form of multi-cluster management to be able to manage all these environments in an efficient way from a small platform team that can take care of all these environments. So there are different types of solutions that you can use, like Day2IQ, DKP, Ranch, etc. One has some more feature than the others, and you have to do more or less depending on which solution you choose. But in the end, you need a solution that helps you to centrally manage the lifecycle of all these environments, meaning that you can create new clusters, that you can update the clusters, that you can shut down clusters, and it should be as easy as creating a cluster YAML, pushing that to Git, and then all the things will be done automatically. So, for example, if you create a new cluster, you create such a cluster YAML with defining how the cluster should look like, you push it to Git, then it will be picked up from a central management cluster that will maybe use vCenter APIs to first instantiate VMs on the on-prem infrastructure, install the operating system and Kubernetes, and then install all the add-ons. Or it will use lights out management to provision the operating system directly on the bare metal hardware. There are a few more things that are important about this central management is that you also need centralized monitoring and alerting. So the idea is that as soon as a developer deploys something to one of these environments, to these workload environments, that he will instantly have all the metrics from these applications available in a central location. So he can see all the metrics in his dashboards, he can deploy his dashboards, alert rules in the central location, and monitor all of the clusters. The same goes, of course, for a platform team that manages all these clusters. So what we do here, for example, is that we have Prometheus instances running in all the environments that use remote write to write all the metrics to a central management cluster. And then we have like all data coming together there. And logging, we usually don't do this because of the amount of data. What we do there is that we collect the log files from the edge devices and push them to the central cluster in a cloud, and then have like something like OpenSearch or Elasticsearch to be able to look at the log data. Another thing that's important is also team management. So you have 100 of these environments. So if you want to set up a new team, you just want to create this in a central location, and then automatically for this team, a Kubernetes namespace will be created in all of these environments. Automatically, they will get all their access rights, single sign-on will work for them, and it's all being automated. And you just have to maybe define a new team as a YAML file and deploy this to your central management cluster. Then another aspect is, again, you don't want to write deployment pipelines for all these environments. Instead, what we do here is use GitOps approach to do multi-cluster deployments using, for example, Flux CD or Argo CD, where you then just define in your deployment definition to which of these environments your deployment should be deployed. Could be all of them, could be a group of them, could be just one. And what these tools also bring, or what we add later on, is things like security scanning, policy management, and other things like this. Now, as many of you might know, a further challenge in many factories or many companies is that you have an awful lot of different PLCs per plant, different sensors, and they all come from different vendors, maybe from different time periods. And of course, each plant is going to be different because they've been built at a different time, so they might just have different hardware generations or devices from different vendors altogether. So, and what makes it worse, that all these devices actually even often speak different industrial protocols. So this is just to give you an idea. The list of protocols that Litmus Edge, that's one of these cloud connectivity solutions, supports, don't have to read them all. It's just there are a lot of industrial protocols. Some are more common than others, but at least in brownfield projects, you're going to meet quite a few of them. In greenfield projects of newer, when newer factories are built, you can usually you only have to live with maybe 2, OPC-UA, client server, and maybe something like S7. So how do we deal with this? Well, the first step is obviously to get data from this machine, meaning you need the solution that speaks all of these protocols. So could be OPC-UA in the example. We have S7 here and maybe a sensor that you connect to via HTTP. So need a solution that lets you deploy connectors either to the central cluster or to edge devices that you might need to connect through unencrypted protocols. Now, the problem is that's only the first step because all of these machines, if they come from different vendors, even if it's the same type, so you have a robot from Fanuc and KUKA and so on, they all have different data points, they have different data structures, and if you just get the data and send that to the unified namespace, you will have problem because whatever you're building needs to deal with these different data structures and different data points. So it's extremely hard, if not impossible, to scale a use case across production lines or even across plants, because each time you have to implement logic that deals with these differences. Same goes for data analytics. In a data preparation phase, you don't want to have to handle all these differences. Instead, what you want is a standardized model for a certain type of machine. So we have an example here. We have a type of machine that comes from vendor A and from a vendor B. They have different data points. They have different data structures internally. So what these connectivity solutions must let you do is to obviously connect through these industry protocols to the machines, define which data points you want, get the data points, and that's the really important part, let you define a standardized model for the machines and transform and normalize the data into the standardized model. So you're able to treat these machines in the same way from here on, as soon as you publish them to an MQTT broker. This is not always as easy as it sounds, because sometimes a machine might not have certain data points, so you might have to add an additional sensor and get that data point from that sensor. And so it can get a bit complicated, but you can get quite far with just doing a transformation and normalization of the data. So by doing this, you're then easily able to scale the use case that builds on the standardized model to new production lines or even new plants. So it reduces the cost and effort considerably. So now we got the data, we transformed the data into a standardized model. The next thing we want to do is to make this data available in a scalable manner. And this is where MQTT comes in and MQTT Broker. So we want to use a publish-subscribe mechanism and not point-to-point connections, because the point-to-point connections don't really scale. If you've tried to connect, let's say, more than 5 services to an OPC-UA server from Siemens, for example, you'll know that this is not going to work. Even a S7-1500 will not scale beyond a couple of connections. So instead, what we use is MQTT as a publish-subscribe mechanism. So you publish the data once that you're getting from the machines here on the left through those connectors, and then multiple services, applications can subscribe to this one publish and use that information to do something else. And then again, the idea is that these services also publish the information they create, the results they create in this central MQTT broker, and we bridge the broker in the plant to a broker cluster in the cloud. So all of the data from all of your plants come together in the cloud, so you can build services that compare the data from the different plants, for example, to figure out why one plant is doing something, why one KPI is better in one plant than in the other plant, what are they doing differently, so you can compare the data between these two plants and build additional services there. And now we already publish the data on MQTT Broker. And now this is where the unified namespace comes in, that Walker was talking about. That's not just the technological challenge, but it's more of a mindset, cultural change in your company, because the idea of the unified namespace is to really publish everything in real time in the unified namespace, and not just the process data coming from the machine, the data from the MES, from an ERP. So if there's a new work order being created from the ERP, it's being published in a unified namespace. If the MES calculates some KPI, like some availability, it's going to be published in the UNS. If you get some new material, the information is going to be published. If something is stored in a storage location, it's going to be published in the unified namespace. If you have AGVs, the position and their status is published in the unified namespace. If you have forklift drivers, their position and what they're currently doing is published in the unified namespace. Everything is being published in the unified namespace. So other services, tools, application can consume this information and do something else with it, and then again publish their result in the unified namespace. Like one example might be the ERP issues a new work order for filling line 1 here, and then there might be some service that loads the respective configuration for this work order and reconfigures the machine automatically based on the new work order. So you can completely automate the reconfiguration of machines, for example, for this. Or the MES might subscribe on all the process data coming in from the filling lines and then calculate some KPI and again publish this KPI to unified namespace. So the structure is also based on the ISA 95 equipment model levels here, but you should always adapt this a bit to your specific needs. For example, you might also combine all the KPIs under like a KPI subtopic, or you might not have separate areas and instead just lines, whatever is really fitting for you. So that's the idea of the unified namespace, and this is really essential, and it's more of a cultural change because, like, so far, if you wanted data from the ERP, you had to go to the SAP team, and then it's going to go for weeks or months till you get data from the ERP system, and then they tell you, but you can only query it every 5 seconds because it cannot handle the load, and so on. So this is a transformation from doing this in weeks or months to having it instantly available when you want to answer a specific question that comes up because you have all the data available. Now, we already have the data in the cloud, so how do we get this into data analytics? Very easy, and probably Kai is going to be happy. We add Kafka to the MISC, or some at least Kafka-compatible managed service, which means we typically move all the data that comes in from the MQTT broker also into Kafka, and use Kafka as starting point to do stream processing via Apache Flink or Spark structured streaming, if we can't avoid it. And also to store all of the data into a time series database and into some form of object storage like Azure OneLake or S3, whatever cloud provider you're on. And from where you can then use some query engine or notebooks to query the data and do any form of analytics or build machine learning models on the cloud provider's platform and train your data, train your models, etc. Also, what's helpful is to have a machine learning platform like Azure ML that lets you also deploy models to any on-prem Kubernetes cluster, so you can serve and monitor your models running on-prem as well in the cloud in a central location. Now, let's come to the last success factor, and that's one I think that people are not aware of enough yet. So it's to integrate a data catalog in your platform, because you have a lot of data sources now. You have maybe some OPC-UA data sources on the left, then you have MQTT topics, you have Kafka topics, you have data and object storage, you have some time series DB, you have other data in the rest of your enterprise. And like, how do you discover this data? You need something where people can search for data sources to discover them, to understand them, a place where everything is documented, where the schema is documented, where you can, for certain data sources, even query the data right away. For example, if you use something like Azure Purview, you can also directly query data that's stored in like about 15 or 20 database types, I think. But you also need to document your unified namespace, like what data structures are published there, what does it all mean, so people building systems, building tools really understand the data and don't have to start researching what certain data points mean or where they can find it. So this is really another important thing in such a platform, to have a data catalog to really let people discover data to be able to work with it. And maybe as a, like, if you look ahead, you can even then use this to feed all of your historic data and all of your real-time data into ChatGPT, OpenAI-based models, for example, and enable like your regular employees to become data scientists, because then they can use ChatGPT to ask questions to the data, and you don't need some data analyst implementing some query for the user, but instead they can really interact with the data and ask new questions that nobody wrote source code for. So this is another thing why data catalogs are important, where you really make all of the data sources that you have discoverable and usable. All right, so let me summarize this again. The 5 key factors, 5 key success factors. So I can wake you up tomorrow morning at 3 and ask you about them. So use Kubernetes from the cloud to edge. Use multi-cluster management tools and things like centralized monitoring. Get the machine connectivity right. Build a unified namespace, and also important, build a data catalog. Thank you. I don't have much time left, but maybe...
Take a few questions.
Yeah, a few questions. We still have time.
So Alex Goldberg here, AMRC. Really great presentation. Thank you. We're quite familiar with Sparkplug and we use it operationally. Do you use Sparkplug in your work?
More often not than yes, because of the limitations that Sparkplug currently have. It starts with them requiring you to use quality of service level 0 for all of your data, which is a no-no for many customers. So they don't accept this, so they want to use quality of service level 1 to make sure they receive all the data, especially if you're in pharma or in a chemical industry where you have GXP data that may not get lost. So you have maybe legal reasons that you may not lose the data. So in these cases, Sparkplug is out of the picture right away. And then you have those strong limitations on how you structure your topic namespace. What also problem is that it's very device-centric, so all the data for a device is published under the same topic, and you can't subscribe to individual data tags. That's also an issue. And there are some workarounds. You can, introduce virtual devices and things like that, but because that means that if I only care about a certain data tag, I still have to process all of the data coming from the device and then throw away 99%, and this just adds to cost. So these are examples for reasons why we try to avoid Sparkplug. Sparkplug makes sense if you use a lot of off-the-shelf software where the standardization helps. So I tend to say smaller enterprises that use the off-the-shelf tools, for them Sparkplug is more fitting than for larger companies.
You likely answered the question. The question was going to be how do you take that quite prescriptive topic structure of Sparkplug and put it into a revenue UNS? I think you likely answered by saying.
Okay. Yeah, we put the ISO 95 levels into the group ID, as most people probably do. But yeah, you just don't have the flexibility that you really want. And unluckily, it doesn't seem to move forward in that direction. But I'm still hopeful. it has so much potential. It would be, yeah, sad if they didn't live up to it. There are two parts to my answer. The first one is it helps if you use a machine connectivity tool, for example, that lets you implement some form of governance process, ideally one that uses Git and YAML files where you define everything, and then you can review like merge requests and maybe just deploy this to a staging environment first before you put it into production, like something like Sybase Connectware or -Q Edge that are YAML-based. Make this much easier than tools that are using like more low-code visual front ends like Litmus Edge, because they have to implement it in their tool. So this is one thing I would do. Of course, we only use these GitOps-based approaches and more mature enterprises that are not overwhelmed by the approach. And the second part is you can talk to the -Q colleagues. They have a solution to be able to check the schemas of the messages that are coming in, so nobody is sending any rubbish to your unified namespace.
Since yesterday to fix it.
And even, yeah.
Since yesterday, we are able to fix it also.
Okay, yeah. And not just post it to that letter queue.
Super quick follow-up. Do you use a repo per customer?
Pardon?
Do you use a repo per customer, a Git repo per customer, or do you have a central one?
No, it's always, whatever we do is always customer specific. We don't have any products. We build a solution specific for our customers. So it's always their own Git repos. It's always their Azure subscription, AWS accounts that these things run in. It's not on our.
Thank you.
Take one more quick question. Great. I think this is off now, so it doesn't matter. Great presentation. Thank you very much. Glenn Fry from Australia. I'm interested in your thoughts on how some of these standard models might fit around the work going on from, firstly, OPC Foundation with their standardized models or the companion specifications, but also the bigger picture with asset administration shell and digital product passports that are now coming very quickly to this industry. And
these standardized information models, like, it would be great if the machine manufacturers would implement them. So the general idea is really good. It's just not being implemented enough. Like our larger customers, like automotive OEM, what they do or what we do with them is to define their custom models that they put into the contracts that the machine manufacturers have to fulfill. But of course, not every enterprise can do that. So they put it into the procurement process as a requirement, and then the machine manufacturers just have to implement these models. So in the ideal case, those machines that you saw on the left would, of course, already publish these standardized models, so you don't have to build them yourself.
Yeah, thank you. So actually, Marc is going to be back on the GNS panel.
And I'm also going to be here all day, so